awareness creation and knowledge management. And in this, we have also done quite some work. And the fourth thematic area is investment promotion for renewable energy and energy efficiency in the East African community. The last aspect is working with universities and research institutions on the area of research, development, and innovation. I think I'll leave it at that. I'm sure there are a couple of partners probably out there who look at this kind of scope, and the discussion for today is timely. Let me take this opportunity to invite the moderator of the day. That is Owuor. Owuor has worked in the renewable energy space for the last 10 years, and he has built experience in supporting energy access and climate resilience work in several African countries. Already in East Africa, he's supporting the development of the regional renewable energy policy for the East African community and several other policy-related works. Before Collins joined EACREEE, Collins's main preoccupation was contributing to the development and deployment of innovative models for clean energy access within underserved markets like the slums, displacement settings, and several other areas. Let's give Collins a round of applause as he takes the stage.
Okay, thank you, Yunus. Let's give Yunus a round of applause. Okay, let's just kick it up from there. I know I'm already ably introduced. Just to reiterate, I'm Collins, and I'm happy to be your moderator this afternoon. So, as has been said, let me just repeat. My name is Collins Owuor, for those who are coming in. I work in EACREEE as a junior renewable energy expert. So I want to reiterate the passion that the Alliance for Rural Electrification has had to bring us together in this 10th edition of the Energy Access Investment Forum. I want to believe that so far you've been able to garner a lot, maybe realize some of your objectives, particularly with regards to matching, building partnerships, and also getting the right set of technologies that you feel that you could be able to take back to your various to the various markets where you work in. I would like to thank. Today we'll have 5 panelists who I believe will showcase some of the achievements, some of the lessons that they have been able to garner from the field, particularly with regards to distributed renewable energy. As the topic says, it will be a pitching session. I know we are going to use a distributed and decentralized loosely to mean the same thing. So these panelists work with different technologies and in different markets. So basically, we would want to abstract what are some of the lessons, what are some of the key learnings that we can be able to take home at the end of this particular session. Then generally, we do appreciate the need for energy access, particularly in the last mile communities and underserved markets, as already alluded earlier on. We know that renewable energy actually do present opportunities to achieve this at a faster rate, particularly in achievement of SDG 7, and because energy access through renewable energy has multiple benefits and co-benefits, which not only improves energy security, but also does help us achieve our NDC targets, attain net zero emission targets, and also just decarbonize the economy. So to support this level access, innovative solutions are incumbent, are quite pertinent to be realized, and innovation basically and financing for innovation is something that's key to achieve some of these gains. So while dissecting this topic of decentralized renewable energy, innovation, and maybe some of the experiences from the field, certain pertinent questions come to mind. One of them, how do we approach innovation, particularly within our context, within our respective contexts, and how do we make the most out of innovation? That's something that comes to mind that probably. Another question is, how do we nurture innovation in decentralized or distributed renewable energy? How do we nurture it and how do we sustain it? Then how do we scale up existing models to commercially viable models so as we can be able to achieve deeper and wider impact to our communities and the people that we are serving? Then to answer some of these questions and many more, we will have a dynamic pitching session where panelists will showcase technological innovation and investment trends, shaping the future of distributed renewable energy. Followed thereafter, we'll have a panel discussion, then finalize with a Q&A session where the audience will get an opportunity to pose questions to the panelists. Then, so in the next hour, do expect to appreciate some of the breakthrough technologies that the panelists are going to present. Feel free to carry forward the discussions with the panelists once they leave here, because this particular session is meant for matchmaking. So allow me at this particular juncture to just go ahead and start inviting our panelists on stage. So once they're seated, we'll just begin the pitching session. So at first, I'll want to invite the first panelist, who is Mr. Ayush Gupta. He's the Senior General Manager for Strategy and Global Strategy and Partnerships from Schneider Electric. Ayush is a leader. Is a leader who's had experiences, particularly in business development and financial analysis, particularly in the Asia and the Pacific region. Maybe a round of applause as he comes to stage. Have your seat. Maybe you'll have the next one. Okay. Then my next panelist is Mr. Norbert Taphorn, who works for SkySails. He has a background in electrical engineering with more than 3 decades of experience in that particular field, particularly working in solar, hybrid storage. So basically, he's responsible for business development across the world. Welcome on stage. Have a seat. The third panelist is Ms. Judith Marera, who's the CEO of Lanforce Energy, based in, which she co-founded, and a non-profit based in Harare, Zimbabwe. Judith is a seasoned HR practitioner who serves across different industries, and she's been able to achieve a number of awards like the famous Tony Elumelu Foundation Entrepreneurship Award for 2021. Welcome on stage, Judith. My fourth panelist will be Cleopatra Adwar, who is the programs manager for E-safiri, which is a women-led e-mobility startup based in Kisumu. Just for context, Kisumu is the western part of Kenya. Yeah, so welcome on stage. My final and last panelist is Miss Maria-Elvira Zeman, who works for Turbulent as a business developer, Turbulent Hydro, to be specific. So she's basically involved in promoting business development in the hydro sector, micro hydro sector. Thank you. Welcome on stage. Okay, thanks a lot. So we'll just dive to the pitching session, and Ayush.
Can I just check the slides if they're moving fine? Yeah. Thank you. So good afternoon, everyone. Heavy lunch, I know, long walk. So maybe we are all tired, but we'll try to keep it short and as much as information can be passed on. So we'll try our level best. So just to start, so as Collins was saying, I'm part of the Access to Energy social team in Schneider. And I'll just explain to you about the program. But today I'll be zooming in specifically on the climate smart village concept, a concept on energy and solution which we've implemented in India. And our next mission is to implement as and where possible in Africa as well. So I'll be talking about that. So Schneider's Access to Future program basically is a comprehensive approach where we support universal access to sustainable, safe and clean energy for developing countries. And with that, in 2009, we started off with a program which was focusing on 3 pillars. Which is basically around skill development of people in the field of energy management, basically basic electrician training program or a solar program, so that people have the basic skills to implement solutions in rural areas and rural communities. And out of these, let's say, people who get trained, some of them also want to become entrepreneurs. So that's what the first pillar focuses on. The second pillar is basically our impact investment funds. So Schneider partners with external partners to basically focus on supporting startups which are working in the field of creating energy transition impact or social impact. So we are working to support those organizations. And third, of which I'm a part of, largely the social and inclusive business. So I'll be talking about that today. I'm happy to share that globally, as an organization, Schneider has targets, gives itself targets in the sense that when I was talking about the training and entrepreneurship vertical, the pillar, we have an ambition to train 1 million people by 2025, and we've almost trained about 800,000 people in the field of energy management till date. Also, the second one is about providing access to green electricity to 50 million people by 2025. So again, I'm happy to share that we've already impacted more than 50 million people till date, and we are still working on our next ambition of what do we want to do by 2030, and obviously with a strong focus on Africa. So. So I've obviously given a background of the program, what we do. So basically the social and inclusive business is aiming to provide energy access to improve livelihood and provide socio-economic development. How do we do that? We try to follow an ecosystem approach where we are targeting to work with people who are financing, who are providing funds for development. Then we also try to work and focus with social engineering firms or NGOs on ground and social experts. Then obviously implementation firms or implementation partners who work on the ground and implement the solutions and maintain the system and maintain the solutions, as well as obviously understanding what is the end user thinking, that what are his requirements, so understanding all those challenges, etc. So that's the kind of ecosystem approach we follow, and in terms of that, largely we are focusing on these 6 verticals. Healthcare, because we believe that energy for health is very important, and I think COVID has taught us all that healthcare cannot be neglected, and certainly you need healthcare to be available for all at all the time. We focus on community, rural electrification of communities, providing electrification for education for schools, and then agriculture solutions, which I'll be talking about, gender equality, as well as emergency response. So just a snapshot of what our solutions portfolio looks like. I'll just quickly run past it because I want to move to the topic of interest. So we have solar solutions called Mobile lanterns, which are the basic, let's say, solar lantern providing light as well as mobile charging. The word Mobia means mobile. The second one being Homia, more for domestic electrification for small households, as well as we find application across healthcare, schools, etc. And the third being collective electrification, which is obviously focusing on collective solutions for communities. So here we talk about water pumping and the climate smart village, about which I'll zoom in the next slide. And all our solutions obviously are powered with our EcoStruxure for energy access, particularly the Homaya and the Vilea solutions. So I'll just zoom into today's topic. So Climate Smart Village, what is it? So Climate Smart Village is basically an innovative, reliable and efficient, cost-effective solution which is supported by our EcoStruxure digital platform, which enables remote monitoring of what is happening and what impact is being created. And the aim is to provide reliable power not only for households but also for agriculture irrigation, agro-processing machines, street lights, community loads, and pretty much anything which requires energy in the village. Now, how do we do that? So I'll give an example of projects we've done in India. So we've powered 2 villages through our Climate Smart Village solution. So these are in the eastern part of India called as Jharkhand. So I'll just give a scenario about how the situation of the village is. These are smallholder farmers with less than 2.5 acres of land holding, as well as an income about $600 to $650 annually. So for their crops and for their crop growth, they depend on rain-fed. They used to depend on rain-fed irrigation largely. Now, when we started partnering with our social engineering partner, and I specifically mention it again that the social engineering firm is key on this in this kind of a successful model, because you need someone to be present on the ground. Because it worked well for us in India in a cooperative model where they're creating self-help groups and helping community-led ownership of the assets which are being installed, as well as creating market linkages, empowering women, because the women are able to now run as entrepreneurs, their own produce, they're able to process the agriculture, the crops being grown into, let's say, more processed form, and are able to sell it through their farmer-producer cooperative into the market. Now, how and when did we really arrive at the solution? So basically, we've been working with this partner on ground since 2019 for solar irrigation. And along with this experience, we've had experience of powering thousands of solar water pumping solutions across the globe. And we realized that capacity utilization typically in a solar water pumping for irrigation is just what, 30 to 40% in a year, because irrigation is just part of the cycle, right? So in order to create a more optimized solution where you can use the additional solar energy being generated, we decided to create a kind of a climate smart village concept wherein you combine multiple agriculture loads like milling, it can be leaf plate manufacturing, it can be agro-processing like mills, it can be oil explorer, it can be anything which runs with a motor. So the idea was to have a central architecture, because when you centralize the panels in this case, you're able to prioritize with our EACREEE box, which you see on number 2. It is able to prioritize that, let's say it's really early in the morning and I want all the solar irrigation to be powering the solar water pumping. So that kind of logic can be fed into the EACREEE solution. And subsequently, what are the next important steps in a is it that you want to power the school, or is it you want to have backup power for households? So all of this can be fed into a logic through our EACREEE box. So in order to, we try to maximize the solar capacity utilization, as I mentioned, and it's a batteryless solution because most of the agro processing and irrigation happens in the daytime. So it obviously leads to a lower capex because we are trying to optimize the use of solar panels, and we are almost making it batteryless. The only battery is required if you want to have backup power for households. So I'll just move to the next and my last slide. Sorry, I think I didn't realize. So in terms of some of the impacts, we've seen that it reduces seasonal migration and which keeps families united. It definitely helps in farmers growing 2 or 3 crops in a year, which obviously affects their income increase. They are able to increase their agricultural productivity. They are able to obviously in a way help the environment because through solar we are reducing carbon emissions. Definitely a lot of women empowerment seen since the women involvement thanks to the FPO and the social engineering firm, their involvement has improved by 25%. And definitely another key to success is that if you remember the pillar I was talking about, skills, so we've been able to train 20 people out of the village itself at our training infrastructure to manage and run and operate these machines and the systems efficiently and effectively. I'll just stop here. Thank you.
Yeah, perhaps I start already. The presentation will come. I'm Norbert from SkySails, and I want to show you our solution to harvest high altitude winds with our airborne wind energy solution. First of all, what is high altitude winds? We start there where the classic wind turbines are at the end. So if you see the big wind turbines and the blades go up to 200 meters, a little bit more. We start at 200 meters over ground level and fly up to 600, 650 meters over ground level. Next slide, please. Okay. How does it work? We see here the power cycle. The kite goes up to 200 meters. At 200 meters, the autopilot will automatically start to bring the kite in flying figures of 8. With this, we produce very high pulling forces on the tether and pull out the tether out of the ground station. In the ground station, there is a big winch where the tether is on. By pulling it out, the winch starts to rotate, and with this winch, we connect a generator and produce electricity. The tether is normally 800 meters long. At the end, we can put every length on the winch what we want, but normally we use 800 meters. When the kite is up, he flies in a small angel, so he flies 600 to 650 meters over ground level, and then he makes something, the kiter call it nose diving. He trims down his nose and flies a cycle back to 200 meters. At 200 meters, it opens up his nose, go automatically in the mode of energy production and fly figure of 8 and pull the tether again out. So we fly the whole day up and down between 200 and 600, 650 meters. The system in the picture is our R&D facility in Klicksbühl, that is in the north of Germany, near the Danish border, that operates already for 5 years. And we have another site in Mauritius, operating since 3 years now, and the next system is just under construction in Taiwan. They just assembled the last things, and we will commission it next week. Justin, why are we flying so high? In the wind energy branch, or in the energy calculation for wind, you have the wind speed high 3. That means if you double the wind speed, you have 8 times more energy. Because of that, everybody wants to go higher, 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 because you come higher, so higher will be the wind speed. Sometimes it's only a little bit more, sometimes it's much more, and with this we are able to generate more electricity. And very important, so higher you are, so more stable is the wind. There are not so much turbulences, and that is also for the energy production very important. The advantages of or main facts of our system. We have 50% more yield with the same system than compared with a normal wind turbine. We can fly 24/7, big advantage to solar. We have more than 80 international patents on our system. The Fraunhofer Institute in Germany calculated that bigger systems in airborne wind are able to generate electricity down to 2 cents per kilowatt hour. In that case, they calculate with a 2 megawatt system. That is not that what we have now. Now we are at 200 kilowatts, but the future outlook for our systems are very good. We need 90% less materials compared to normal wind turbines. And our system, our 200 kilowatt system, is designed for 200 kilowatt. We have already an externally certificated power curve for the system, and there is a verified power from 120 kilowatts. In a year, we produce actually around 500,000 kilowatt hours with one system. We will increase it to 750,000 kilowatt hours with the same system, just by optimizing and developing the flying system. At the moment, we are on the left side. We have the PN14 system. This is designed for 200 kilowatts. There we reach levelized cost of energy of 20 cents per kilowatt hour. Tomorrow, we will launch the next phase, the growth phase, our next system size. That is the PN2X. This has levelized cost of energy less than 10 cents. And the future outlook are megawatt scale systems where we can generate the electricity for less than 5 cents per kilowatt hour. Actually, the system has a kite of 180 square meters. Next generation will fly between 300 and 450 square meters, depending on the wind situation. And the growth phase 2 will use kites larger than 1,000 square meters. Main advantages of our system, we are nearly movable. You can very easily deconstruct it and bring it to another site. Perhaps important for rural electrification, if the grid is coming and you have to go to another site, very easy to do. We are typhoon proof. If the wind speed becomes too high means for us more than 25 meters per second, then we land the system. The kite will be roughed automatically and put in a box, and everything is hurricane and typhoon proof. Yeah. That's for the moment. I'm happy to answer your questions. Also, after the session, I'm available if there are more questions. Thank you.
Good afternoon, everyone. My name is Judith Marera from Zimbabwe, and I'm the founder and CEO of Lanforce Energy, which is a woman-led for-profit social enterprise, and we are in the renewable energy space, specializing mainly in biogas installation, biogas digester installations. The main idea behind providing biogas solutions to the rural communities is that because they do have access to waste, which they can easily turn into energy and can help and impact so many lives in the rural communities. That is the reason why we had to impact or to roll out the biogas solutions to our rural communities. We work with various communities from households up to commercial. And in Zimbabwe, currently, in terms of population, the main challenge behind providing this solution is because 70% of our population in Zimbabwe do lack access to sustainable energy solutions. They mainly rely on unsustainable solutions like firewood, charcoal, in some cases, cow dung and crop residue. And this is very much detrimental to the health of most of the women and children, because they're the ones who spend most of their time worrying about energy to cook, especially. So you see many women and young children tagging along, trying to look for firewood, and that also steals time for these women and children. For children, especially in rural areas, the girl child is also mainly affected by this challenge of energy poverty in Zimbabwe. Before they go to school, and maybe coming back from school, they need to look for firewood so that they can prepare for their next meals. And the mothers, even if they're left at home, beside the other household chores that they have to do, like tending to the fields, they also lose out a lot on some productive time that they can utilize in doing some productive tasks. So with our solution, you see that these women are now being empowered, and even the girl child. Our solution is biogas digesters, like I said. We are doing the installation of these biogas digesters from small households to commercial, depending on the energy requirements of each customer segment. So we do have different customer segments that we serve. As long as they have access to waste, they can have access to biogas digesters, which now address this challenge of energy access and in rural areas. And we are providing a clean and affordable source of energy in the form of biogas, which we do provide on credit, because we realize that the main challenge, especially with the rural people, is the capital. They do not have enough money to invest in biogas digesters. And still, up until today, we know that it's still a challenge for most of these people, because they still cannot afford. The cost is still a bit on the higher side. But as an organization, that's something that we also try to work on. Prior, we were working on the traditional fixed-dome biogas digesters, and we realized that these biogas digesters were quite expensive for an ordinary Zimbabwean, because the majority of these people, they live on less than $10 a day. So we try to find solutions and ways in which they can also have access to clean and affordable energy. Hence, we introduced the prefabricated systems that are a bit cheaper compared to the traditional fixed-dome biogas digesters. And for those who do own livestock, it's quite easier for them, because they can sell probably one or two, then they pay a deposit, then they'll have to pay the rest of the amount in installments, and thus having access to clean and affordable energy. And in terms of our investment opportunity and impact, what we are looking forward to in the coming years, we are looking to distribute around 6,131 cook stoves by 2028 to help rural households have access to clean and affordable energy. And on top of that, we are looking forward to install close to 3,000 biogas digesters by the end of 2028, just so that we improve on the livelihoods of these rural communities, so that they have enough time to also concentrate on other productive projects. Because with biogas, the good thing is you can use it for so many things besides clean cooking. It also provides these rural communities with a byproduct, which is an organic fertilizer, which helps reduce the cost of chemical fertilizers, which is obviously quite expensive, one, and not easily accessible, especially to the rural communities. So with them having access to the organic fertilizer, they tend to have an increased yield in their agricultural production. Then they can sell the surplus on the market, thereby earning enough income to sustain their families. And they can also enter or do other projects like fish farming, hydroponics, and expand their income bases. So this is what we are trying to do to make sure that these communities are empowered. We are also going to be creating jobs. Besides the jobs that we have created before, we are also going to create more jobs for the rural young boys and girls so that they stay away from drug abuse, and we also try to reduce unemployment rates that is hitting our country. We train these young people as our community-based agents and technicians, including the women. So most of our agents, they are women whom we work with, who do understand also the pain that their fellow women go through in search of firewood, so they can easily convince the other women to invest, even if they are farmers. And we are also trying to reduce the greenhouse gas emissions that is resulted in by dumping waste. When we look at the urban areas, there are a lot of landfills, and those landfills, they are emitting a lot of methane into the atmosphere. So that's the methane that we want to try to capture and produce gas, which can be used for various cases in the household, at institutions, even at commercial level, because you can also generate electricity from biogas. So what is it that we're looking for? We're just looking for partners we can work with in order for an ordinary rural Zimbabwean family to have access to clean cooking, to empower these rural communities. So you can partner by donating biogas digester for a community, or you can partner with us in terms of deploying this technology to most of the rural communities, especially the farmers that we work with in Zimbabwe. Open for further discussions if you need to hear more about what we do. Thank you so much.
Good afternoon, everyone. My name is Cleopatra Adwar. I'm the head of programs at E-safiri Charging Limited. I'm inspired by African women on the continent. The mother of our founder, Carol Ofafa, walked for an hour from home to the nearest health center. The grandmother before her walked 8 kilometers every day to go to the lake, to the shores of Lake Victoria, to buy fish and to take it to the market. Today, African women work 40 million hours a year to access basic services and opportunities. E-safiri was founded to change this narrative. So E-safiri is solving for the lack of reliable, affordable, and accessible mobility solutions by providing renewable energy-powered battery swapping and battery charging. We are also offering flexible pay-as-you-go ownership for the women and youth in the rural and peri-urban areas. The sustainable mobility total addressable market on the continent is at $4.9 billion. E-safiri is targeting $249 million as its serviceable market. Since our registration in 2022, we have reduced 200 metric tons of CO2 emissions, which is equivalent to 50 return flights from New York to Nairobi. We've also supported 400 women in different community-based organizations and also youth in the rural parts of Kisumu and Homa Bay in Kenya. We are looking to expand our charging stations and also our fleet, the electric two-wheelers and also the electric cargo loaders. Sorry. You can see from my presentation, we are looking to have by 2030, we've deployed 390 charging stations. The charging stations are installed, we fit ice makers in the charging stations. So we are also looking to have 390 solar powered ice makers. We also deploy ice makers because we believe productive uses of energy go hand in hand with sustainable mobility. We are looking to fundraise $1.3 million to expand our network, to expand our fleet, to improve access to productive use of energy, and also we are looking for a CFO, Chief Financial Officer, who is like-minded and shares in our values to power Africa's sustainable future. Thank you, and we are looking to connect with you all.
Yes, hello. Well, thank you everyone for being here with us. Thank you for the panelists because it's really interesting to learn about all these innovative solutions. I think we are all super connected in finding solutions and alternatives for the distributed renewable energies. So I'm Maria-Elvira Zeman from a Belgium company in micro hydropower, Turbulent. And actually, I want to introduce this presentation by hoping or inviting you to see all the electricity that I hope you see in these images. So water is a source of energy that we can convert in energy. So it's not only solar, it's not only from different sources. Here you see like different type of rivers, not only rivers, you see irrigation canals, and you see infrastructure that exists already. And it's not infrastructure that is far away in the middle of nowhere. It's infrastructure that exists close to places where we live, and we can harness the energy that is accumulated here. So Turbulent is a company that started in 2015. And actually, as innovative solutions, we were thinking, okay, how do we disrupt the status quo? How do we can do hydropower, but aim it for rural places, for places where it's difficult to go? And especially wondering, okay, how can we break the old paradigm of having huge hydropower that is working with dams, breaking the natural flow of the river, that takes years to implement, that is very costly, and also have collateral situations like environmental or social displacements that are things that we know we don't want to have. So every system has advantages and disadvantages, and we wanted to create a solution that could address these type of problems. So what is then our vision? Our vision was really to go for a sustainable solution based on hydropower and especially decentralized hydropower. So instead of building a huge dam and making one single source of production. We rather identify the flow that there is in a river, and we identify the different drops that there are in a river, like a rafting type of river, right? And that's what something that we find in this geography, that we find in different places where there are mountains. So whenever we identify these in different places of the river, we can produce there, we can install small units that are also closer to the communities using this energy. Why? Because normal settlements, they look for water. So settlements close to water, and we can produce energy from the water. Then part of the innovative way of thinking is, okay, deployment. We are able to deploy very, very fast. Just to give you an idea, when all the data that we need and all the permits are there, in less than a year we can have micro hydropower running and producing. And especially, as I mentioned before, in proximity to the users, creating some saving in transmission lines, etc. And very importantly, with an environmental respect, especially for fish. How do we do that? Well, with this very simple kind of whirlpool shape structure, in which from the source of water, again, not only a river, it can be an irrigation canal, we make a bypass to take the water that we need, respecting always the ecological flow to live in the river. And that water we guide to enter in the basin, in a basin in the shape of a spiral. And that spiral is guiding the water to hit the blades of the generator that is in the lower part of the basin. That way, we generate the electricity and immediately we return the water to the river. As simple as that. As simple as identifying a water drop of 2 meters and 2 cubic meters per second. That's the minimum we need. So just to give you some examples of cases where we have been working, I want to bring you for a moment to another side of the world. You come with me to Colombia, where we have been working with the indigenous community of the NASA people. That's in Colombia, in the middle of the country, where you have these amazing mountains, not only amazing, but super remote. So to get here, we need to take an airplane from the capital, Bogota. We fly there, then we drive 2 hours from the main door to the main village, and then we take a 4x4 and we drive 3 hours to get to the school where we can stay and where we have our meetings with the community, to then walk 1.5 hours up to the place where the river is. We work with this community. They presented 5 different rivers to us, and finally we found the one that was suitable for our technology. And I think what is very nice from these type of projects is that we get there and we don't say, like, what can we do for you? The question is, what can we do with you? Because they already identify the resources of energy that were available in their territory, and they had a clear business case, which is extremely important, of what to do with this energy. This is a community that has been isolated for many years, and only recently, 8 years ago, they got a connection from the grid. It's a connection that is unstable, but is there. So what is their proposal? This is a group of 11 communities distributed along, is 7,000 people. Half of the people are women, having exactly the same situations as the panelists just mentioned, putting hours in mobility, putting hours in finding wood for cooking. So now their business case is to sell the energy to the grid. They conform themselves as an energy community. They will get the income, and they already have in mind what they will do with the income. For example, cooking plates to replace wood. So as you can see, this is a cycle. This is like electricity will enable many other things, and with our turbines and with the amazing rivers that are crossing this territory, we are able to work with them and provide this solution. Now let's get closer to here where we are. South Africa. In the region of KwaZulu-Natal, the province, we have a partner working in irrigations. The grid there has a lot of instability, and that is affecting the irrigation pumping system, and they rely a lot on diesel to be able to irrigate and produce the magnificent crops that they need to produce, mainly corn, oats, wheat. What we have been working with them is in this nice but challenging river is not only to pump the water, but then to produce energy that will feed the pumps. And the beauty of this is also how to use things that they were already using with this new system. So we are creating a hybrid system together with solar. This river is not having the flow that we need constantly all over the year, but then that's when we can combine with other technologies and have like a very solid solution for this customer. Of course, you can imagine the impact that it has in the number of almost 100 tons of CO2 reduction that this project is bringing. So we are talking here, sorry, in the previous case, we are talking about 150 kilowatts. It's 3 turbines, each turbine of 50 kilowatt. And in this project, we're working also with 3 turbines generating 75 kilowatts that we will complement with about 50 kilowatts of solar. You can imagine that there are several challenges in this type of topics. For us, it's extremely important to do knowledge transfer, because imagine for this region in Colombia, it's not that we are present there and we can just go and solve every problem. So we need to train, and we train the local people to be able to take the ownership of their own system. It's actually part of the innovative solution is how simple the maintenance is. And that allows to have also to train people and have them taking this ownership. Monitoring, of course, extremely important. We deployed together with a software that allowed us to do remote monitoring together with our customers so that we can remotely support and do also preventive actions. So this is what I wanted to share with you. And I hope when you see like these nice sources of water that you think in electricity with turbulent turbines. Thank you so much.
Okay, thank you so much, Maria. So we'll go to the second phase of this particular session. That is the panel discussion. So I'll just pose the first question to Ayush Gupta. How does your latest product specifically address the challenges of affordability and scalability in the last mile energy access? And what sort of financing or partnership models are you exploring to ensure wide-scale adoption in underserved communities or underserved markets? Thank you. Over to you.
Thanks, Collins. That was a long one, but I'll try to break it into simple parts. When we talk about affordability, so obviously when I was talking about the climate smart village, we are talking about a battery-less system largely because we are focusing on productive loads which largely work during daytime. So because of that, obviously the capital expenditure cost for the entire system comes down. So that's why it becomes affordable. Along with, obviously, we are trying to optimize the use of the solar panels by centralizing it and prioritizing the order in which the machines and the loads and solar irrigation need to run. So because of all of these parameters, the cost of the system becomes much more affordable. Along with, obviously, when you have a battery-less system, then obviously the maintenance and the operations part, the cost of that also comes down. So this is about affordability. In terms of scalability, I would say that what I showed you in the presentation was the full-blown system. However, we can start small. When I say start small, it can be as small as one solar irrigation pump, as well as any agro-processing which is being done in the region which we are installing the solution. It can be up to that small a system and scaled up to a much bigger system as and when obviously the funds are there, and then obviously once the impact is seen, because it directly impacts the income of the farmers. So once they have more income, then obviously the migration rates reduce, and once the incomes are there, the crops, the number of crops increases and the income increases. That's why the affordability and the scalability definitely increases. So this is obviously affordability and scalability, and obviously partnership. I think I've mentioned a word, ecosystem, at the very beginning of when I was starting my presentation. So we are trying to work in an ecosystem model, and I think that's the need of the hour. Why we say that is because it's not alone maybe a Schneider Electric's job, or alone maybe the NGO partner who's working on the ground. All of us need to come together and collaborate, and that's why the partnership is important, that the funders who are providing the funds are there, but equally important are the people who are implementing the solution on the ground. Equally important, and I think the most important, is the social engineering firm or the NGO, which is really enabling the community engagement, setting up all the market linkages, setting up the ownership of those assets, which I was talking about, as well as obviously having a cooperative model, and most importantly also what we focus on is the skill development. So if you enable local people to be trained in managing the system, doing the basic maintenance, as well as operating it efficiently, then I think such type of climate smart village or any other technology becomes very successful. Thank you.
Okay, Mr. Norbert, you already talked about the SkySails airborne wind, which I think I read somewhere it's called power kite. And I know you've already alluded to some of the differences with the conventional wind turbines. So how do you think it compares to the conventional wind turbines in terms of efficiency, scalability? I know you've touched on that already. Maybe you could just repeat that, and also particularly with regards to deployment in remote and underserved areas. Thank you.
Yeah, first of all, once again, our technology is just at the beginning. It's the first of its kind in the world that you can buy, and with this, it's not really fair to compare it with classic wind, but I will do it a little bit. So first of all, we fly much higher than the classic windmills. With this, our efficiency will be higher. We have more wind potential. We can produce more power on the same place. Compared to the materials you use, we have the advantage that we have 90% less compared to the classic wind turbines. We don't need hundreds of tons of concrete to build a system. Our system in Klickspiel has 3 small foundations. Each of them is 2 meters of 2 meters and 40 centimeters deep. That is everything on concrete we need. Yeah. With this, our system is nearly movable. You can disassemble it very easy. It takes 1 day. If everything is well prepared, we need 1 to 2 days for assembling the system, so we can bring it very easy to other parts and to other sites. I would avoid to do that every day because you need permits for our system, and the special permit you need is a flying permit. There we always ask for a restricted area around our system, like it is usable for hospitals, for military installations, and also for the airports. Nobody is allowed to fly there, and we ask for the same. And that's not so easy to get it, so don't think that you can bring it every week to another site. Should be a little bit longer. But normal wind turbines are placed there where they build, and you don't move them away. The transport is also an interesting thing. When you transport a big windmill, you need special trucks for the blades, for the tower parts and everything. For our system, you need a normal truck. The ground station is a normal 30-feet container. We have the grid connection module that is a 20-feet container. And at the end, you need a little bit for all the things you have to add to the container, and third container and third 40-feet container. But normal containers, no special transport. When we compare the service and maintenance, in our system, everything happens on the ground. The system is landed, you can do everything on ground. With normal wind turbines, you need to go up on the tower and do it there. Perhaps you need special cranes, special lifts to bring up spare parts and whatever. In our system, everything is on the ground. Installation, no special crane, just a normal forklift to unload our system, to put it on the tripod, and that's it. So we have many advantages. From the size, we are small. It's the first of its kind, but we have already ideas to build bigger systems and to bring down the levelized cost of energy and be much more comparable to the big windmills.
Sure. Okay. Just having a problem with this other mic. Hopefully you'll bear with us. Ms. Judith, I know you talked about some of the challenges that Lanforce is experiencing, particularly with the deployment of the biodigesters, particularly in rural areas, to be specific. In your view and in your quest for the long-term sustainability of some of the projects that you're implementing, how does the maintenance of the biodigesters happen? And what support mechanism do you put in place so that to maximize the energy output from those biodigesters? Thank you.
Okay. Okay. Thank you so much. Yes, I have highlighted some of the challenges that we realized when we started deploying the biogas digesters. Mainly, it was the issue of maintenance of these systems. The users previously were not getting enough information and education on how to maintain their systems in the long run, so that they could be operational for the number of years that they are supposed to be operational. So in trying to address one of those challenges, what we do is we do what we call user training, whereby we train communities on biogas, educate them, what is biogas, what are the benefits of biogas. And once a customer comes to us, after doing the installation, we also provide that user training on how they're going to be maintaining the systems and how they can also detect any leakages within their biogas digesters for safety. We see that safety is one of the most important things that we need to talked about with our clients because we have that slurry pit whereby the byproduct is discharged. So they also require to protect the area where the biogas digester is installed so that we prevent loss of life, be it of children or other small livestock within the household compound like the chickens. And with this knowledge now being passed on to the users, we've seen that in terms of issues of maintenance.
So the other battery swapping points are supported by the centralized hubs. We have the modular and scalable technology where E-safiri's tech stack support modular battery swapping that is easily relocated or expandable. On the role of partnerships, personally, E-safiri, we have different partners. We've partnered with the local or the county government, and working with local authority helps in securing land, policy support, and also in the last mile deployment, which is crucial in scaling up. strategic partners, other partners that we have are with the border cooperatives, which enables E-safiri to tailor financial and subscription models to enable the riders to procure the bike and the batteries at affordable rate. Another partnership is with the digital lenders and the fintech, which enables E-safiri to offer pay-as-you-go or lease-to-own models, which is making the EV units to be affordable. Partnerships with the energy companies, strategic alliances with the solar providers or mini-grid operators enables E-safiri to operate in the remote areas because we are able to access energy. That's all from my end.
Thanks a lot. To the last panelist, Maria, I know you already talked about the benefits of microhydro, also given us vivid examples of some of your project sites in Colombia and KwaZulu-Natal in South Africa. How does your microhydro system actually adapt to varying flow conditions? Because I think you already alluded to the fact that the changing river regimes, of course, affect, it's something that's realized that affect particularly performance of big hydro projects. So how does the system that you promote vary to those particular changing conditions? And maybe just touch on some of the advantages that the microhydro has over other traditional small-scale hydropower solutions. Thank you. Over to you.
Yeah, thank you. What you're asking is extremely important and is the basis of the studies that we do in our projects. A river is a living being, is a living creature, right? It's changing. We have extreme phenomena like El Niño, La Niña. So we always have to start by historical flow data. Normally in places where we can have daily average flow, we gather that. And in many rivers that are well monitored, that is possible. In very, very remote places, like for example, this project in Colombia, we have been working in an hydrology model and validating that model by doing local measurements, and that is possible. That's the only point is that then we have to add time to the project. So normally we can deploy in one single year. For this project, we needed 1 year to do and to validate the whole model, because indeed it's important to have not only the average situation, but the extreme values, and then to design and to select the model of the turbine that will be the most efficient for that flow available. So definitely changes in the flow and the river is a fundamental part of our study and the design of the project. Among the advantages that you're mentioning, well, definitely the civil work simplicity. We are not comparable with conventional hydropower. We don't need house power. We really need to do the inlet, we need the canal and the basins. And for that, you need sometimes to excavate or you need to elevate, but it's extremely simple. 6 months should be enough, 8 months maximum to build the whole setting. Definitely, then not only the simplicity, but as I mentioned before, the fast deployment that we can do. Once the data is there and the permits are there, we have the turbine running. I think it's important also to mention, as the topic that Judith said, maintenance. The whole system has been designed for a very simple maintenance. It's like a car. We need to change the oil of the gearbox once a year. That is our main maintenance. And if you want to have an idea, it's like 1.5 of the percentage of the capex. So I think that's, in 3 topics, what I will say the main advantages are. I will make a comment. Okay, now you're, no, I will make a fast comment because I really like what you said, like, okay, we can, it's not comparable really to like the conventional mills. I think when we are now all working in these alternatives, maybe the question is it comparable? Or maybe the question is, can like a conventional technology be installed here where we are doing this? I think what we're trying to look is for solutions where other systems cannot provide a solution. Then sometimes we are really treated by legislation like with the same ruler as for other type of projects or technologies, while we offer something maybe different. And that's the work we have to do in lobbying with governmental or regulatory institutions to make them understand how we are different from like more conventional or like well-known historical solutions.
Okay, thanks a lot. I was really itching to ask the next set of questions, but I know some of them we've already touched on them, particularly with the relation to partnerships. Unless there's only anyone among the panelists who would want to touch on the kind of partnership they are seeking in this particular event. Maybe you can go ahead, just as we wind up. Any of you? The kind of partners that you are seeking, maybe in half.
I think all of us here, we should have like at least a word. For us, it's very interesting to partnership with mini-grid developers that are looking for a source of energy that can be with rivers or combined with solar or other things. Cleopatra, go ahead.
For us, we are looking for capital partners, the venture capital firms or impact investors to fund our expansion of the fleet and charging station, mobility partners, yeah.
Thank you. For us, we are looking for partners, especially DFIs, so that we can have access to working capital in order for us to be able to deploy the units that we want to deploy and also grow in terms of the business growth within the country. We want to open more regional offices, employ more people, and make sure that everyone has access to clean and affordable energy.
Yeah, we are looking also for project developers and partners which afterwards also can operate the system, make the service, make the maintenance on the system. We are not able to do that from Germany, and that makes no sense to do it from Germany. We need local partners who can operate the system, who can make the service. We will offer training for that, and we show them very clear how it works. We will have also a remote control that we can see everything in Hamburg, what is happening in the system in real time. But at the end, we need partners for which are able to do the service.
From my side, I would just like to say that it's great that we meet at forums like this, but for me, what will be important is to figure out how do we maintain the momentum before we meet next. How do we collaborate in between? How do we do meetups, follow-up sessions, etc.? It's great to have those matchmaking sessions, but maintaining the momentum after such forums and meetups is very important. So I would definitely count on everyone who feels that we are working in a similar area of interest to come together and maintain the momentum so that we continue the good work. Thank you.
Thank you so much, the panelists. Some of the things that actually come up that came up during the discussion is the need for an ecosystem model just to ensure that there's complementarity, so that this, in an ecosystem, there's a lot of, you can be able to achieve a lot of benefits. And also, some of these projects, I know something was also talked yesterday during this particular afternoon session, the simplicity of projects. She's touched about it, the need of these particular projects, these particular innovations to meet the needs of communities. That is something that's quite vital. That's something that we need to keep in mind as we innovate and also build partnerships. And we also realize that we can't do some of these things on our own. There's need for partners. There's need of people in IT, funders. I mean, you need also the community themselves, local governments to assist with the permitting and what have you, so that you can be able to achieve your project in time, and also to gain the social capital from the community to implement those particular projects. So I just want to end it as that, but reiterate that innovation is something that's quite important, particularly in diffusion of not only the technology, but also the skills across countries, across regions, so that we can be able to achieve universal energy access. And I think considering that we are a few years to 2030, if we are to achieve SDG 7, I think there's needs to put a lot of funds towards innovation so as to be able to sustain it, so that it can be also be able to help us achieve SDG 7 in time. I want to thank you, my panelists. I also want to thank the audience. I don't know if I was told to wind up. Can the audience ask a question? I'm told no, not really, but you can take it up with the panelists immediately after this. You already know their faces, you know their names. Maybe at coffee break, you can be able to ask them some of your burning questions. Thank you, and have a restful evening.